Lately, I've been reading Knuth's The Art of Computer Programming books. As I've been reading, I started taking notes, so I started making this video series. It's more of a quick note style rather than an in-depth analysis of Knuth's books, so I strongly recommend picking them up and reading through them if you want to deep dive through the material. Knuth starts off his books by building up a definition for an algorithm, and by building up, I do mean it. He starts off with the history of the word algorithm, the possible roots, origins, etymology, etc. Once Knuth finishes the history of the word algorithm, he then presents Euclid's algorithm. He hasn't told us what an algorithm is yet. He's just showing an example of the very first algorithm according to him. Euclid's algorithm goes as follows. You first take two numbers. The book calls these M and N, but that's kind of hard to distinguish verbally, so I'll call them Mike and Nettie. Once you have the numbers Mike and Nettie, you then divide Mike by Nettie and keep the remainder and put that into a new variable. We'll call it remainder. Then you check to see if the remainder was 0. If the remainder is 0, we just return Nettie, because that means that Nettie divides into Mike evenly. Otherwise, well, we need to try again, but this time we use Nettie and the remainder instead of Mike and Nettie. And that's it. That simple recursive loop helps us find the greatest common denominator of any two numbers. Here's a C++ example that does the algorithm. And here's a JavaScript implementation as well. Now that we've seen an algorithm, Knuth finally decides to define what the word algorithm means. It's kind of similar to a recipe or a technique or a procedure, but it's also not like those. Knuth's problem with the other things like recipes and procedures is that they're often too vague to be what he considers a true algorithm. Having the step add a pinch of salt or cook on medium-high heat just doesn't cut it for Knuth. Computers want exactness, and they tend to break in weird ways if you're too vague or too loose with how you describe things, even with modern AI. And so Knuth tries to solve this problem by adding additional properties an algorithm must have in addition to being a set of instructions. Knuth's properties are first, finiteness, second, definiteness, third, input, fourth, output, fifth, effectiveness. I'm going to just do a very quick notes version. First, finiteness. The algorithm must always finish in a finite number of steps. No infinite loops, none of that stuff. Second, definiteness. Definiteness means that each step is unambiguous and precisely defined. Or you could give your algorithm to a random developer you've never met and they'd be able to write an implementation. Third is input, which means that an algorithm defines what input it uses. Fourth is output, which means the algorithm both does something and it returns the result in some way. Fifth is effectiveness, which is basically Knuth's way of saying somebody can implement the algorithm. The algorithm can't rely on any weird stuff like the existence of imaginary particles or having an infinite number of digits of precision. It has to be something that can actually be implemented by a human being, and the human being can teach it to the computer. And so with those 5 extra properties, Knuth now has a definition for what an algorithm is, and he can start going into other things like how do you analyze it, which is basically big O notation, which I've done in a previous video, as well as give more examples of algorithms, which he does later on in the book. For the first section of the book, that's pretty much it. If you want to see more of this series, then go ahead and give a like and subscribe, and I will see you next time.